Thank you. That's very helpful. We're set to go. I appreciate your guys' help. The fundamental theorem of algebra, incredibly difficult to prove. So easy to state. It says for every polynomial of degree n, it has exactly n roots, or solutions or zeros. So if you have a 5th degree polynomial, you have 5 solutions. If you have a 4th degree polynomial, you have 4 solutions. But it has other components to it. You see, the fundamental theorem of algebra doesn't work out unless we say something intelligent about imaginary numbers. And before I get to that point, if it has these solutions, so every polynomial coefficient a and solution c1, c2, c3, and c sub n, it can be written in this form. A times x minus c sub 1 times x minus c sub 2 times x minus c sub 3 times x minus c sub n. And all that means is that not only does, say, a 5th degree polynomial have 5 solutions, it means every single polynomial of 5th degree you can write in factored form. In fact, every polynomial can be written in factored form. So this whole idea about some things factor and some things don't, it's a complete lie. It turns out that every polynomial does factor. We may just not see it right away. Okay? So everything factors. The last thing is this. If polynomial p of x has a solution of a plus bi, which means it's an imaginary number, right? Okay? Then another solution must be a minus bi, the conjugate. And what that teaches us, is if a plus bi is a solution, then so is a minus bi. It is the conjugate. That tells us that imaginary solutions come in pairs. They're never by themselves. If you have one, you always have another. It's almost like, suppose you have twins, okay? If one has a birthday on, say, Monday, November 23rd, then another one's going to have a birthday on Monday, November 23rd. It's 22nd. I'm sorry. So just stop making fun of me all the time, okay? Except, and this is my goal through it, because I come across a lot of sets of twins being a teacher. Would you agree? I want to find one that was born at like 11:59 at night, and then another one that was born at, say, like 12:03 of the next day. See if they had 2 different birthdays. Like, wouldn't that be kind of neat? You know what I mean? Like, for example, hey, how about this? So what time were you born?
Like 6:35, I think.
Even if it was like, say like 6:05 and then 5:58, it would be 2 different days in a different country. You know what I mean? Yeah, well, I'm hoping. Whatever. No, I just think it's fun. I'm just, kind of hoping for the, what I mean? All right, so here we go. The conjugate is also a solution. So, good news or bad news? There is no bad news. Good news only. Good news is this. 40% of your test is made up of the types of problems, the 3 problems we're going to do today. 40%. That means if you figure out how to do this stuff, you have a great chance of scoring super high on the test. Are you ready? Here's what we're going to do. We're going to take this polynomial. We're going to identify the total possible number of solutions, the possible number of real and imaginary solutions, the positive and negative real roots, the possible rational choices, all the roots of the polynomial, and then we're going to write the polynomial in factored form. We got a lot of stuff. Fortunately, you know how to do basically all of it already. We start with this, complex roots. After that, we're going to do the positive real. And then the negative real. Once we determine the positive and negative real, that will allow us to determine the total real. Once we know how many real ones there are, then we can determine the number of imaginary ones. Then we'll go about finding our solutions, which we'll have to list our choices for the rational roots theorem. And finally, we will list our solutions. Step by step, here we go. How many complex solutions exist in this polynomial? 4. Complex numbers exist in both the imaginary as well as the real. Yes.
What is a complex root? Yeah, that was actually.
Excellent question. Okay, let's try to summarize it as this. We are now in a situation where we say, you've always been talking about the real numbers, right? And within the real numbers, I'm going to just talk about 2 subtypes of numbers. First of all, I'm going to talk about rational numbers. Can somebody give me an example of a rational number? 1 is, 9/4 is, okay, anything that can be expressed as a fraction would be a rational number. Can somebody give me an example of an irrational number? Okay, pi. Root of 5. Are we all on the same page with those?
Yeah.
So when we talk about the rational roots theorem, it applies to these type of numbers. The rational roots theorem does not apply to those type of numbers, but these are all real numbers. We then have another set of numbers, the imaginary numbers, such as the square root of -4, I, 6i. Would everybody agree that those are all imaginary? Okay, together they make up the complex number system. So, for example, we would say that 9 is a real number. It's also a complex number because it's 9 plus 0i. See that?
So anything is a complex number.
Everything you can think of is a complex number.
So then where's 4? Like why is it 4? Because doesn't it go with power?
Yes. So the reason why we have 4 complex roots is because it's to the 4th power. You'll write that down right away every time.
Well, what about 16?
This number?
Yeah. Is it not a complex number?
16 is a complex number.
But then why would it 5 if it's to the 4th root?
Let's do the example and then see if your question still exists. Because right now I don't know how to answer that. There are 4 complex solutions, okay? So what that means is we have 4 total solutions. Some of them might be real, some of them might be imaginary. That's what that means. Let's go through and figure them out. I'm going to first determine the number of positive real solutions. How do I determine the number of positive real? How many sign changes are there? 1. That means that there is 1 positive real root. It crosses the x-axis on the right side exactly once. We all okay with that? Okay, now I'm going to do the number of negative real. How do I determine negative real? P of negative x. So will this stay x to the 4th or will it change to negative x to the 4th? Stays x to the 4th and I have minus 16. Is everybody with me still? So how many solutions are there? There's 1 negative real. So if there is 1 positive real and there is 1 negative real, then how many total real are there? There's 2. No, there can't be 0 because there is 1 and there is 1. See that? So very common. Ella did what probably 50% of people would do. She subtracted 2. And I'm going to tell you right now, if there is 1 and there is 1, then there's no way there's 0, right? We know for a fact that there are 2 real solutions. There are 2. One's positive, one's negative. So this is the new part. If there are 2 real and there's a total of 4, then how many imaginary would there be? 2. The number of real and the number of imaginary have to come up to the total number. Better? Okay. Now, if I were to use the rational roots theorem, I would like to list my rational choices. That means I would need to look at my P's and my Q's. Can somebody tell me what my choices would be? Plus or minus 1, 2, 4, 8, and 16. Good. At this point, you can decide if you're going to factor or use the rational roots theorem. I would encourage you to, if you can, to factor. Does this factor? Yes. So P of X will factor to? Does it factor again? Does x squared plus 4 factor? Nope, it doesn't. Okay. So that means I have solutions of what? Two and negative 2. So notice 1 positive real solution, 1 negative real solution. That means that my other 2 solutions are imaginary. And they lie right here. We got x squared is x squared plus 4 is equal to 0. I will solve to find out what x is. I subtract my 4. X squared is equal to negative 4. And x is equal to plus or minus 2i. So I have positive 2i and I have negative 2i. Notice, again, I have 4 solutions. I have one that's a positive real. I have one that's a negative real. I have a total of those 2 reals. And then I have 2 imaginaries. Perfectly diagnosed ahead of time. So you can see that on the test that all those should line up for you. If they don't, you made a mistake, right? Great way to verify your work. Now, the last thing it asks us to do is to write it in factored form. Want to make sure we're on the same page. We always write x minus the solution. So x minus 2, x minus negative 2, x minus 2i, x minus negative 2i. Now, I know most of you would not write it in that way. Most of you would write it as x minus 2, x plus 2, x minus 2i, x plus 2i. And that's fine. I'll accept either or. But I have to make this point that it always starts out x minus. If you change it afterwards, that's fine. But always start out x minus. That's to save you from making a mistake later on. Question?
Yeah, so for the I, would we do it like, so we got the I to plug the thing in again, but how do you get the I? The imaginary numbers.
So I had to solve the x squared plus 4 equals 0.
Oh yeah, that's why we're a negative.
Yep.
Okay.
Flip it over. Complex solutions, positive real, negative real, total real, and then we have imaginary. We have our choices. We have our solutions. And I'll write it in factored form. The total number of complex solutions or roots or zeros is, as Wendy said, 3. Nice job, Wendy. I would now like to try to determine how many of them are real and how many are imaginary. We'll see what we can figure out. How many positive real will I have? There are none, because there are no sign changes in that polynomial. P of negative x, if I plug in a negative x, will it become positive 8x cubed or negative 8x cubed? Plus 1. How many sign changes are there now? There is one negative real. So there are no positive, there is one negative, so how many total real are there? There is exactly one total real. So there are exactly 2 imaginary. There cannot be 0 imaginary, right? There's got to be 2 imaginary. Exactly. So the total real and the imaginary must add up to the complex solutions. Complex solutions exist of both the total and, or the real and the imaginary. Okay, all right, so if we're going to use the rational roots theorem, my p's are 1 and my q's are 1, 2, 4, and 8. So can somebody list for me my choices? 1/2, 1/4, and 1/8. Oh, Mr. Gentz, come on. Do a better job. So, this created some consternation, third hour. There were some people that really did not like the idea of using the factoring method here. Some people just want to go ahead and use the rational roots theorem. Go ahead. I'm going to factor it if it factors. Anybody see all those factors? It's the cubes. Yep, this is a sum of 2 cubes. What do you multiply by itself 3 times to get 8x cubed? 2x, yep. What do you multiply by itself 3 times to get 1? And it'll stay plus. So, this is a... Yeah. All right. In order to get this front part, I square the front. What is 2x squared? 4x squared. To get the back, I square the back. What's 1 squared? To get the middle, I multiply these 2 together. 2x. This is always plus. This is opposite. Okay, there's my polynomial. What is the solution here? Negative 1/2. So I therefore have a solution of negative 1/2. That's one of my solutions. Notice I knew it would be a negative real solution. Got it. Right there. Done. Now I move on to the next part. Does this factor? Yeah. Nope. Not at all. If it doesn't factor and it's a quadratic, what do we use? Quadratic formula, which is amazing and awesome. Your calculator doesn't work here. Negative b, so positive 2. Plus or minus the square root of?
B squared, which is 4.
Minus 4 times a times c. All divided by twice the a value, so 8. What do you get underneath the discriminant? 4 minus 4 times 1? Good. 2 plus or minus the square root of negative 12 over 8. What is a perfect square you could take out of negative 12? Negative 4. So 2 plus or minus root of 4, or negative 4, excuse me, root of 3, all over 8. What is the square root of negative 4? 2i roots of 3 over 8. Notice those are all divisible by 2. Factor out, or divide out the 2. Factor and divide the 2. You get 1 plus or minus I roots of 3 over 4. There's my other 2 solutions that we knew would be imaginary. Why? Because we did our work at the beginning. And that's what we came up with.
imaginary, they won't be in the constant.
No, because these are only for rational numbers. So like the square root of 2 wouldn't show up there either. Okay, just to diagnose, one real, it is negative. There are no positive reals. There's a total of 3, and 2 of them are imaginary. Got it. Last thing I need to do is write it in the factored form. X minus negative 1/2 times x minus 1 plus I roots of 3 over 4 times x minus 1 minus I roots of 3 over 4. And we got one slight change then, okay? If I multiply these x terms out, notice I just get x cubed. But my original polynomial isn't x cubed, it's 8x cubed. And that's why the fundamental theorem of algebra said that it might factor to needing a constant in front. See that? So what constant would we put in front? 8. So that is the factorization of that polynomial.
Where did we get? Okay, now how do you check that?
Okay, hold on. Look at my original polynomial. See how it's 8x cubed plus 1? If I were to multiply these out, do you guys agree I would just come up with an x cubed? I need an 8x cubed. So therefore I pop the 8 on there. Okay. All right, last one. Total complex solutions, positive real, negative real, total real, imaginary. Choices, solutions. How many complex solutions are there? There are 3. How do I determine the number of positive real? How many sign changes are there? So that means I have 3 or 1. I don't know if it's 3 or 1. Why are we subtracting 2? Because imaginary numbers always come in pairs. So that's why you're subtracting 2 each time and not just 1. See it? If there is an imaginary solution, there's not just one of them. There would be 2. Okay, that's why we don't just go down by 1 each time. It's 2. All right, how do I determine the negative real? If you have negative x, what happens to this? So I get negative 2x cubed minus 13x squared, be a minus 26x, and be a minus 10. Are there any sign changes? So there are no negative real. So how many total real are there? There's 3 or 1. Excellent. So let's suppose that there are 3 total real, then there are how many imaginary? None. Suppose that there is 1 real, then there are 2 imaginary. So it kind of matters the order that you do these in, right? All right, my choices. Got to look at my P's and my Q's for my choices for rational roots. Got 1, 2, 5, and 10, and I got 1 and 2. One, 2, 5, and 10, and then 1/2 and 5/2. So you take all these over 1, right? And then you have 1 over 2 is 1/2. 2 over 2 is just 1. We've already listed that. 5 over 2, which is new. And then 10 over 2 is 5, which we've already listed. Because you would have 5 divided by 2. Okay, so let's try to finish this off. Can you see how it factors? I can't either. So that means we have to use the rational roots theorem. So we got to try plugging in some numbers. What would you like to plug in? Okay, so I get 2 minus 13. That's negative 11. Plus 26 is 15. Minus 10 is 5. That didn't work.
I should probably ask this.
Yes.
What if we run out of time on the test just because we couldn't figure out what to plug in?
You could try negative 1. We got 2, negative 13, 26, negative 10. Negative 2, negative 15, 15, 41, negative 41, negative 51. Oof. Somebody else? 2. Let's go. 2. Got 2, negative 13, 6, negative 10. 2, 4, negative 9, negative 18. 8, 16, 6. Shoot.
Negative 2.
Can somebody tell me why we're not going to do any negatives? Nobody caught this before.
Oh.
There are no negatives, guys, right? Let's not do any negatives, okay? All right, so you could try 5. Can we try the 1/2?
Yeah.
Let's try the 1/2. So I drop the 2. 1/2 times 2 is add, and I get negative 12. 1/2 of negative 12, negative 6, add, and I get 20. 1/2 of 20, add, and I get 0. So if 1/2 worked, that means that I have x minus 1/2 times 2 x squared minus 12x plus 20. Notice how we came up with the 1/2. It is one of our choices, and notice how it is positive. So we knew we weren't going to have any negatives there. Does 2x squared minus 12x plus 20 factor? Yeah, take out a 2. We get x minus 1/2 times x squared minus 6x plus 10. Does x squared minus 6x plus 10 factor? Definitely not, right? No two numbers that add to 10 or multiply to 10 that add a negative 6, right? Too bad I wasn't negative 7. Could use negative 5 and negative 2, huh? Okay, so we have to use the. So I have negative b plus or minus the square root of. B squared would be 36. Minus 4 times 1 times 10. What do I get underneath the discriminant? A negative 4. So 6 plus or minus the root of negative 4 over 2. What is the square root of negative 4? 2i. Very good. So your solutions are 1/2 and 3 plus or minus I. Which, as you can see, that's 3 complex solutions, 1 that's real, that's positive for a total of 1 real, 2 that are imaginary. The last thing we will do is write this in factored form. X minus 1/2 x minus 3 plus I, x minus 3 minus I. Have to put the 2 on the front. Excellent work. Please take out your worksheet.